questions about their drone and some of the technology that's actually inspired by or inspired in. Is that okay with you?
Yeah, sure.
All right, great. So in the meantime, let's wait for your team to get started, and let's see if you can start. We'll do a live commentary as it goes.
Even though if it's too exciting, perhaps I will stand up later.
Alright, so now, how many members are in your group?
In the group or the team? The team. Yeah, so, okay, I have to let me count now. So, we have in the arena, we have Michael, Schwo and Sjoerd. Michael and Schwo have been working really a lot on competition, also Sjoerd. There's back home, there's still a bachelor student, Isabella Hash. And there's a few professors involved at home, Christopher and myself. Yeah. But,
now, are all of you guys graduate students or engineers, or what is your background?
So I'm a professor. My I lead the scientific principles. And we have, for example, Sjoerd is a PhD student, Schwo as well, but Michael is a master student. And what I think is nice is that we heard about this competition in May, and some of the students joining the team didn't even know how to program. Yeah?
Wow. Fast learners.
Very fast learners, and now, I heard this morning they did very well, so now we just hope that also during the real competition they do really well.
Well, that definitely speaks well of the program.
But it's very cool to see that they learned how to program, how to program drones. What we do is, I would say, really challenging, because we take a commercial, very evil drone, very good drone. It can crash many times without breaking.
So it's approved by you guys, or tested by you guys?
We tested it very well these days. But it has two cameras. It has one to the front, and it has one to the bottom. It has all kinds of other sensors on board as well. But so we're doing all of this, we could say, with binocular vision. And so we don't use stereo vision for distances. We use one eye, basically.
That's very interesting. Now, you mentioned before that rival inspired. What do you mean by rival inspired? Oh, there it is. Okay. So, guys, the first run is ready to go. So, while it's going, we'll have.
I'll get mark. Okay. Conduct. Good luck. On my mark. 3, 2, 1, go.
Going forward. Okay, get it first.
Take off. It does not touch the gate. Yeah, inside the gate.
We have two different mechanisms. So,
turning.
Closed gates, you consider them different than open gates. So if you look at these FPV races, then actually they have these open gates as well, and they're more just to provide the pilot a pathway. Yeah. So they don't. I think they're also perhaps even less strict. But okay. So it should fly here, of course, over it.
Hey guys, you need to get my signal to the time record. You need electro.
Stop flying.
Ready? Yeah. Okay, on my mark. 3, 2, 1, go.
Okay, here's the second attempt.
So the takeoff is actually a bit tricky because it's very close to the net. So that's why actually they're going to restart it now. So what we actually do is we make it fly forward a little bit, which typically should send it off.
Okay, give me a signal.
Gotcha.
Ready? Okay, ready. Okay. 3, 2, 1, go.
There it goes. Much better takeoff.
Yeah, but I hope. So we don't do much about direction. We slightly steer it, look here. Just. We don't fly through them as the other gates. Like the other gates is really good at the gate, position on top of the gate, go through. Here we just go straight, also because we want to go as fast as possible.
Yeah, is it trickier because it is another gate?
Well, it's not trickier to pass through, of course, but we don't.
Ready?
3, 2,
1, go.
Soft takeoff.
Let's give them big hands and cheer them up. Hey, good. Take care, everybody. Ready? 3, 2, 1, go.
I think if you count all gates, that was 6 gates. But actually, because it's first gates, we don't watch them too much. We only count the close gates. So for us, it's 2.
There we go again. Look at that. Very smooth. Very good.
We didn't make a map of the environment. And so in our lab, we make many small drones. And for example, one of the drones that we have made is the Delphi Explorer. And this is a 20-gram flapping wing that is completely autonomous with onboard vision and processing. So on such very limited robots, we do not want to make maps of the environment.
3,
so it's just
2, 1, go.
So it's just linking together behaviors. So we link together simple behaviors. We try to navigate a bit as perhaps a honeybee would do and follow these landmarks. Of course, the task it has to do today is pretty unnatural because it has to find two shapes. We have to get
So far, he's already cleared 6 cases on the 3rd try, which is very good.
6 gates, yeah, so far.
Okay. So having said that,
3, 2, 1, go.
goes again.
Actually, yeah, again, this is for us one of the most difficult parts. And what happened a second ago was that when we did the part with that, then the sonar senses in that thinks it's too low. It's really okay, let's go now. That's fine because it's a very tight space here. So actually, at home we had a track that was more, for example, circular. Then we could go through that very smoothly. But it's very tight space, and you have close to each other.
1, go!
So yeah, normally we navigate, and our motto is okay, perhaps less precision, but faster. So actually, the racing for us seemed like a really good idea to join. But actually, we still need quite precise control in all these tricky corners. So yeah, I just hope that we will get to the first stretch and we'll take an additional gate.
Now, would it be different if the borders were solid and not kinetic? Would that make a difference in the way that the camera would perceive the boundaries?
Yeah, so the frontal camera actually, it was a short-term project, so we didn't put any obstacle components in. So the drone only has sight for all the orange things. In this orange jungle, we try to recognize gates and try to control. So this is the thing that happens like 60 times. Typically we go earlier, but of course it's cost some time. So yeah. So we need to go to the behaviors and we're going to really far
quite a bit.
Yeah, it's for us it's we were not so smart this year, so we subscribed to 3 competitions. The first competition we subscribed to was the Outback 2 weeks ago in Australia, and there a drone has to go 30 kilometers to a place, autonomously land, collect a blood sample, take off and come back. And for this we made a hybrid drone. So what is a hybrid drone? It's partially a helicopter and partially a fixed wing. And that's why it's very efficient in forward flight. And we were the only entry that had a hybrid wing joining. All the other participants had petrol, like gas engines, and we had just electric. But because there's a fixed wing, if you transition in the air, the hybrid becomes much more efficient, and we became second place there. Now, this competition is now, and next week we have a competition in China, the INA. So actually our whole team was already working on the other 2 competitions. So that's why we are working with, well, before the competition, inexperienced team, but now they're really, I would say, yeah, pretty experienced already.
Job training, right?
Yeah. So some of the problems are that, yeah, of course we have to cut a lot of corners in order to be on time. So one of the things that we don't take that much into account is the battery level. So as the battery is decreasing now, it may be that the drone flies slightly less fast, so that it turns a bit too quick. And yeah, I think that the advantage of our method is that it's really fast. The disadvantage is that we have still quite a bit of tuning on these parameters, and that's why that's basically what we're doing now. This is 300 grams. So for us, I mean, I think compared to many of the competitors, this is a small system. But to us, this is a big system. So we do a lot of research on tiny drones, like pocket drones of 20 grams, 40 grams.
20 grams?
Yeah, and we make them autonomous.
3, 2,
with
1,
stereo
go!
vision, optical flow. What we run on here is optical flow. We have a pretty straightforward color detector for the color. And then we do shape fit. We don't process the entire image, so we only process some pixels per image. try to find a shape that fits, and then we tag on to that. So this allows us to be really quick because, okay, perhaps it takes a few frames to find a gate,
2,
but
1,
when you have it,
go.
you keep it, and you're really efficient.
Back in the lab, how many different designs of these drones do you have?
Yeah, so we have many different designs of drones that we work with. So we work with quadrotors, we work with helicopters, we work with hybrids that I'm talking about, we work with flapping wings. So we do a lot of research on the design of these things as well, but mostly on control and also the intelligence. And the intelligence, yeah, again, it's pretty different.
Okay, you have 17 minutes, still 17 minutes.
Visual odometry and
3, 2, 1, go.
And it's off.
Sjoerd, maken jullie zo een beslissing wat je doet, of met deze doorgaan of andere batterijen?
De batterij alweer.
Ja, oké. Ja.
Die andere hoeft niet meer, want die gaat natuurlijk maar te testen.
Ja, precies. Oké, perfect. Sorry.
Yeah. So now, like, well, how would you differentiate probably your drone from some of the competitors out there today?
So yeah, if you look at the competitors today, most of them rely on stereo vision as well. So the stereo vision is useful because, well, first you immediately see distances, and it helps with the gates because actually we developed a stereo solution back home to do also the gate detection, but we used a really tiny stereo vision system. It could detect the gates, but our stereo vision system only goes until 4 meters, and the distances are a bit bigger here. I think that the competitors have better, high resolution, heavier of course, stereo vision systems that allow them to filter out all the stuff that is far. So we, on the other hand, we just look at color. So we have, again, this jungle of orange in which we try to find the gate that we want to use. Now you will see the QR codes on there, but QR codes, they're pretty detailed. And if you take a normal camera, you take a static picture, then you can recognize them. But if you fly and you have blur and you have tilted angles, then it becomes really difficult. So we're not using the QR codes. We tried that, but...
3, 2, 1, go!
And the difference between the research that we do and the research that you typically see is that we always do everything on board. So, the research we presented at IROS, it's all on board. So we have, for example, a flapping wing that starts flying. It doesn't know how to see distances yet with a single camera, but it has a strong infrared sensor, and when it almost collides, it turns away, but it also learns what it saw. And then after some minutes flying, it can avoid obstacles without...
And that's the intelligence factor, obviously.
Yeah, so it's like a baby robot. Before it starts flying, it doesn't know. After flying, it does. And the difference is that we do everything on board. So for example, also if you think of swarming, so because we work with these small systems, of course we have a lot of interest in swarming, because the small systems are very limited. Now, often you see that there is an external system, or external beacons from, for example, wideband, that allow the drones to localize themselves globally and tell it to the others. Now what we do, and we released a paper on this on the archive a few weeks ago, we want to use onboard stuff. So we use Bluetooth, which is already on tiny drones typically, to find distances between drones and then estimate. So they only communicate what they know to each other, so they know their velocity and heading. They communicate it, they estimate it, and then they can avoid each other in small spaces. So yeah, it's really all about, like already Professor Moon said in the beginning, if you have a disaster and you want your drones to explore an area, and you don't want to go in and place beacons or some external system, so yeah, we want them to be completely autonomous. Yeah, so no human operator. And that's also why I was so happy with this competition, that they announced different categories, like a category for onboard processing
and outboard.
So I hope they can copy the run they did this morning, because